What is interpretation and model in propositional logic? So first we will study about propositional logic. Okay, so first remember we are only discussing for propositional logic first. After that we will discuss for first order logic. So interpretation comma model in propositional logic. In propositional logic, what is the interpretation? Let's see. See, in propositional logic, if I give you some expression, like let me give you P or Q. Tell me, is it true or false? This expression I am giving you, is it true or false? This is my question. Let me call it G. Is G true? Is G true or false? Tell me. If you want to find the truth value, then what will happen? Let's assume these are the variables. So if you want to find the truth value of this, then what you need? You need the truth value of P comma Q, right? Yes or no? So that's the point. If you want to find the truth value of this, then the question is, what is the truth value of P comma Q? You need the truth value of P comma Q. Okay, so that is the point. If you have any propositional logic expression, then to find the truth value of that expression, you need the truth assignment to the variables. Correct? Yes or no? Any expression I give you. So basically what we need, I can say what we need. We need the truth value of P. We need the truth assignment. This is what we need. We need truth assignment to P comma Q. Okay, so here P comma Q are propositional variables. These are propositional variables. Then in this situation, so what we need truth assignment of to P comma Q. So this is the idea. So if you have any propositional logic expression, if you have propositional logic expression, any propositional logic expression, for example, if for example you can say like A or B implies C, like this example you can notice. Now in this situation, okay, to find the truth value of this, let's assume A comma B comma C, these are the propositional variable, and this is your propositional expression. This is the expression. This is the expression. So to find the truth value, what you need? To find truth value. To find the truth value of this expression, propositional logic expression. In short, let me call it PLE. So to find the truth value of PLE, we need the truth assignment to the propositional variable, right? We need the truth assignment. What is the truth assignment to the propositional variables in that expression? And this assignment, so okay, so this is the information we need. Do you need any other information? For example, if I give you this expression, let's assume A or B implies C, and this information I'm giving you that A is true, B is false, C is false. Do you need any other information? Tell me. Do you need any other information? No, there is no other information you need. So this is this information you need, and only this information you need. You need this information, and there is no other information you need. So this is called interpretation. This is called interpretation of G. This is called interpretation of G. Okay. So now you can notice in this interpretation, let me call it I1. In this interpretation, what will be the value of G? In this interpretation, what will be the value of G? In this interpretation, the value of G, what that will be? That will be true, right? Yes or no? I can say in this interpretation I1, the value of G will be true. Yes or no? Agree? This is the very simple point. So interpretation, this is the interpretation of this formula. So interpretation is nothing but a truth assignment to all the variables. So what is the interpretation? You can notice the definition of interpretation. Interpretation is basically the assignment of truth value to each variable, to each atomic variable. Okay, so very simple. This is the definition. See, this is just the motivation, but the formal definition is this. The formal definition, I can say that interpretation basically means that to every variable you are assigning truth value. That is called interpretation. The assignment of Boolean values to the propositional variables of a sentence is called interpretation. This is the definition. Just read this definition. This is your definition of interpretation. So for example, this is interpretation. P is false, H is false. This is interpretation. P is false, H is true. This is interpretation. So tell me, for this expression, how many interpretation will be there if I have two variables? For two variables, how many interpretations are there? There are total 4 interpretations, right? If you have this expression you have total 2 variables you have. I can say there are 2 propositional variables you have. So how many interpretations are there? How many interpretations we have? For G, how many interpretations we have? So the answer is very simple, total 4. These are the interpretation. A is true, B is true. This is the interpretation. A is true, B is false. This is interpretation. A is false, B is false. This is interpretation. And A is false, B is true. So total 4 interpretations we have. We have total 4 interpretations. So basically the idea is this, that in propositional logic, I can say number of rows is the, every row in the truth table is the interpretation. So this is another definition for interpretation in propositional logic. Yes or no? In propositional logic, what is the definition of interpretation? Interpretation is basically a row in the truth table. Interpretation is basically same as, it is same as row in a truth table. Okay, basically this is same as truth assignment to variables. All these things are same. So if you have 3 variables in your system, so let's assume you have a system. In that system, if you have 3 variables, then how many interpretations will be there? If you have 3 variables, then for 3 variables there will be 2 power 3 interpretations. We have total these many interpretations we have. So this is the idea. If you have n variables, then there will be 2 power n interpretations will be there. Now let me tell you some of these interpretations. For some of these interpretations, for example, if I give you this example, like you have this A or B. Now you can notice we have total 4 interpretations we have. So in short, let me write it in. Okay. So we have total 4 interpretations. But for how many of these interpretations this is true? Tell me, for how many of these interpretations this expression is true? This expression is true only for one interpretation. So I can say only for one interpretation. Sorry, only for 3 interpretations. I can say there are for 3 interpretations. For 3 interpretations, this G is true. So these 3 interpretations are known as model. We call them model. This is the definition of model. So what is a model? Model is interpretation for which our expression is true. So in propositional logic, remember I'm talking about propositional logic only. After some time I will discuss the first order logic. But in propositional logic, what is model? Model is an interpretation for which expression is true. An interpretation for which expression is true. For which expression is true. Very simple, right? Yes or no? Isn't it simple? So for example, if you have 2 variables, then there are 4 interpretations are there. So rows basically in the truth table, these rows are basically the interpretations. Now you tell me one thing, interpretation is also called word. Now how many models are there for this? For this negation P, if I ask you for this negation P, how many models are there? This is the question. So this is the expression I'm giving you, negation P. How many models are there? In the system you have, remember, in the system you have 2 variables, P, Q, these 2 variables you have. In the system you have these 2 variables. My question is, for this, how many models we have? How many models we have? So here you must focus here. See, okay, in your system you have 2 variables. If you have 2 variables, you can define this. See, with 2 variables, can I define negation P? Like I have P, Q, but I can define, right? I don't use Q. See, it's the situation like this. In my system, I have total 2 variables I have. Tell me, if I want to define expression, is it mandatory that I take all the variables? Tell me, is it mandatory that I take all the variables? No. Who told you to take all the variables? See, in the system, you have these two variables, p comma q, but I can say, I can define, I don't have to take all the variables. I can define negation p. What will be the negation p? That will be 1100. So how many models this negation p has? This is a model, this is a model. So there are total four interpretation we have, and there are total two models we have. So how many models we have? Number of models the question is asking. So number of models will be 2. So the answer is 2. Okay. It's like this. So basically this G has two variables, but okay, we are not using both the variables. G has two variables, but we are not using both the variables. So this is the idea. Now, if your system has only one variable, basically what it means your G, okay, in your system only one variable. Now, how many models are there? Now answer will be 1. How many interpretations are there? Interpretations will be 2. Interpretation is fixed, but only one model will be there. Okay, now tell me, for this, how many models you have? Number of models. Number of models. So for this, you have 2 models. For this, you have how many? Only one model. For this, there are 3 models. For this, there are 3 models. For this, there are 2 models. Model is interpretation in which your formula is true. So you can notice an interpretation is model if your formula becomes true. If your formula becomes true, then that interpretation will be called model. Means your interpretation will satisfy the formula, then this interpretation will be called model. This is a question in UGC NET. UGC NET 2018. So what is the answer? Tell me the answer here. So you have total 4 variables A, B, C, D. How many models are there? The question is asking how many models are there for this statement. You tell me how many interpretations are there. If I ask you, so basically in your system you have, it's like this. It's like this. You have total 4 variables A, B, C, D. And the formula is B or C. This is the formula. So basically in your system you have 4 variables, but your expression only has 2 variables. How many interpretations? Tell me number of interpretations, you tell me. Number of interpretation is fixed. That is 2 power 4. That is fixed. That will be 16. Number of interpretation is 16. But how many models are there? Number of models. So remember you have total 4 variables. You have 4 variables. So model means those interpretation where B or C is true. Model basically means that B or C must be true. Okay, remember, if you want to make this true, then how many choices you have? If you want to make this true, B comma, then how many choices for B comma C? This is true, then how many choices for B comma C we have? For B comma C we have 3 choices, right? For B comma C we have 3 choices. B comma C together we have 3 choices. For A, how many choices? 2 choices. For D, how many choices? 2 choices. So the answer will be what? 3 into 2 into 2. Yes or no? Correct. For B comma C together we have 3 choices. This B comma C, they together they have 3 choices. A has 2 choices. D has 2 choices. So finally answer will be 12. So the number of models will be, answer will be 12. So there will be total 12 models, but their interpretation is same, that is 16. This is another, okay, remember here one common mistake that students make. What is the common mistake? What do you think, what should be the common mistake? Here the common mistake is that if you say answer is 3, the common mistake is answer equal to 3. This is the common mistake. Why this is the common mistake? Because remember, you will just think B or C should be true. Okay, B or C should be true. Then you will think that, okay, I have 3, so there are 3 ways. So you will think that, okay, there are 3 ways. This is the common mistake. The common mistake is ignoring The common mistake is ignoring A comma D. You are ignoring A comma D. That is the common mistake. Okay. Now let's see this. This is another UGC NET question. What is the answer? Another UGC NET question. So you have total 4 variables. How many models? Again, the question is asking how many models. If I ask you how many interpretations, then what is that? First to tell me number of interpretations. That is same, right? Number of interpretations, that will be 2 power 4. That is 16. Number of interpretations will be 16. How many models are there? How many models are there? Basically, this should be true. Remember, basically your expression is like this. In your system, you have total 4 variables. In your system, you have total 4 variables, and your expression is negation A or negation B or negation C or negation D. Okay, tell me when it will become false. Instead of writing, okay, instead of finding model, you can find co-model. Remember what is co-model? Let me tell you. Let me tell you what is co-model. What do you think? What is the definition of co-model? Co-model means an interpretation for which formula is false. This is called co-model. An interpretation for which formula is false. For which expression is false. This is called co-model. So here, how many co-models will be there? If you want to make it false, there is only one way, right? See how many co-models. So just find number of co-models. Just simply find number of co-models. Number of co-models will be 1. Because if you want to make it false, if you want to make this complete thing false, if you want to make this complete thing false, then what you have to do? Then this should be false. This should be false. This should be false. This should be false. So basically A must be true, B must be true, C must be true. So I can say number of co-model is only 1. So number of models is total 15. In this situation, if number of co-model is 1, then number of model will be total 15. So I can say number of co-models. What number of models? What is that? That is, what is the formula? Number of models is equal to number of interpretations minus number of co-models. Right? See here what I'm saying. If you take this, for example, if you take this expression, like let's assume you have this expression A comma B, and your expression is negation A implies B. Now in this situation, you have total 2 variables. Total how many variables you have? 2 variables. Okay, 0 0 0 1 1 0 1 1, and this is your formula G. So what will be the truth value? The truth table, what that will be? So you can notice that it will be false only when this is true, means when A is false and B is false. When A is false and B is false. In this situation, this will be false. In all other situations. Now let me tell you, all these are called interpretation. See, all of them are interpretations. All of them are interpretations. So how many interpretations? Total 4 interpretations. This interpretation is called co-model. This interpretation is co-model. This is called co-model. This interpretation is called co-model. Because here you have false. And this interpretation, these interpretations are called model. These interpretations are called model. Is it clear now? The definition of model, co-model, is it clear now? Let's take just another example. Let's assume you have a formula, and this is like you have total 3 variables, and so let's assume you have 3 variables, and the formula is A bar. Now tell me how many models are there, how many co-models, and how many interpretations. Now in this situation, you have total 3 variables, A, B, C. Remember, total 3 variables you have. Okay, so you have total 3 variables. So how many interpretation will be there? There will be total 4 interpretation. Okay, so And this is your formula negation of A. Negation of A, that will be 1 1 1 1 0 0 0 0. Now let me tell you that all these are called interpretations. All of them are interpretation. Okay, all of them. These are interpretations. So how many interpretations we have? Total 8 interpretations we have. All of them are interpretations. These are called, remember, yes or no? These are your, I can say, here you can notice here G is true. So these are your models. These are the models because here your expression is true. And these are co-models. And what can you say? You can say that these are co-models. These interpretations are co-models. Anyone has any doubt right now? Still, do you have any doubt? So the answer will be here. The answer will be 15. So number of models here, you can notice number of models will be 15. Number of co-models will be only 1. Now, so here you can notice. Sometimes let me tell you one more thing, that if a complete set of formula is given to you, if a complete set of formula is given to you, then for that formula, like for example, if I give you complete set, okay, so let's assume I give you a complete set. Like this is called knowledge base, I told you, right? So if I give you a complete set of formulas, so let's assume you have a set of expressions, set of propositional logic expressions. So you have set of propositional logic expressions like, okay, E1, E2, and so on, En. Then tell me, what will be the model for this? For this, what will be the model? Let me call it KB. Now, what is the model for KB? What that means? Model for KB, what that means? That means all of them should become true, right? When all are becoming true, right? So I can say basically those interpretations for which I can say those interpretations for which all the formulas become true, for which all the expressions become true. Okay, so for example, if I give you, let's assume I give you, this is the set of formula I give you. P implies Q, Q, R. Then tell me how many interpretations are there. First, you tell me the number of interpretations. Number of interpretation. Number of interpretation is decided by how many variables you have. So total 3 variables you have. So that will be 2 power 3 and that will be your 8. So basically that is 2 power number of variables, number of propositional variables. So this is very simple. So total interpretations are there 8. How many models are there? How many models are there? Remember, model means how many models are there? Model basically means that all of them should become true. If you want model, then what it means? How many choices for Q? Tell me how many choices for Q? Only 1. Because Q must be true. I am finding model. Okay, model basically means that, okay, what is model? Model is an interpretation where all of them are becoming true. So I can say that this also should be true. This also should be true. And this also should be true. Now you can notice that for Q only one choice I have. For this Q only one choice I have. For R only one choice I have. But for P, how many choices I have? For P, I have 2 choices, right? So for P, I have 2 choices. Correct? So for Q, there is no choice because Q must be true. R must be true. But for P, I have 2 choices. So how many models I have? 2. And how many co-models? Automatically, number of co-models will be 6. Because number of co-model means number of interpretation minus number of models. So that will be 6. Another example, this, which of these interpretation is model? Alap, this is the system. Look at the system. See, Alap, we have 3 formula. This formula, this formula, this formula. I want model. Model means all the formula must be true, right? All the formula must be true. This Q must be true, this R must be true, and this must be true. Every formula must be true, right? Yes or no? This is a formula, this must be true. This is a formula, this must be true. This is a formula, this must be true. So for Q, there is only one choice because Q must be true. So Q has to be true. Q definitely has to be true. Okay, tell me about here. Which of these interpretation is model? So which of them is model? Which interpretation is model for this? So definitely you can notice whatever interpretation you take as a model, then Q must be true. So Q must be true, right? Q must be true. And if Q is true, then what should happen? Tell me. If Q is true, then definitely P must be true, right? So Q must be true. Automatically P also must be true. So I can say which of them is model. You can just check it out. See, Q must be true. See, here Q is false. So this is definitely not a model. Because Q is false, so this is definitely not model. This interpretation is definitely not model. And you can notice all are true. So yes, this is a model. I can say this is definitely a model. Remember one thing, Q must be true. And if Q is true, then P must be true because Q implies P. This is Q implies P. Remember, this is Q implies P. So here I can say Q must be true and P also must be true. P also must be true. And then you have S implies R. This means S implies R. So S implies R. So here both are okay. S implies R. So I can say this is not model. This interpretation is not model. Everything else is a model. So I can say this and this. These are models. Is it clear? So the answer will be this one. How many models are there total? How many models are there total? So for this knowledge base, how many models are there total? Number of models, total number of models. Remember, number of interpretation you already know. Number of interpretation PQRS, that will be 2 power 4, that will be 16. But how many models are there? So you can notice definitely Q must be true. Q definitely must be true. And you know that if Q is true, then P also must be true. This must be true. And remember, Q is already true. So this P must be true. So for P, there is no choice. For Q, there is no choice. So I can say for P comma Q, we only have one choice. It only have one choice. And this only have one choice. What about R comma S? For them, we have three choices. For R comma S together, R comma S together, they have three choices. So the answer will be number of models will be, so I can say number of models, that will be 3. Number of co-models will be 15. Okay. Q can have two choices. No, Q must be true. You have three formula, this formula, this formula, this formula. You have three formula. So Q must be true. If you want model, then this Q must be true. And if Q is true, then automatically P must be true. For R comma S, we have only three choices. For R comma S together. So number of models will be 3. Okay, let's move on. So I hope all these concepts are clear. Now, in terms of model, in terms of interpretation, you can define satisfiable. So tell me now, what is the definition of satisfiable? Now in in propositional logic, now you can change the definitions. In propositional logic, tell me what is the definition of tautology now. If I ask you the definition of tautology, then what that will be? Tautology means for every interpretation is model, right? Tautology means every interpretation is model. Tautology basically means every interpretation is model. This is the definition you can use. Every interpretation is model. Every interpretation is model. What can you say about contradiction? What can you say about contradiction? What can you say about contradiction? Every interpretation is co-model. Right? Or I can say there is no model. I can say contradiction basically means there is no model. there is no model. Similarly, you can define satisfiable. What is satisfiable? There is some interpretation which is model. There is some interpretation which is there exists a model. Basically, satisfiable means there exists a model. Satisfiable basically means there exists a model. And what is the definition of valid? I told you valid and tautology, these are same in propositional logic. This we have already seen. In propositional logic, these two things are same. Same in propositional logic. Okay, so like this you can define. What is unsatisfiable? That is contradiction. Unsatisfiable basically means contradiction. You already know unsatisfiable means contradiction. And that simply means there does not exist any model. There does not exist any model. Okay, so these are the definitions. Now we will study interpretation and model in first order logic.